Hello, welcome to another video from Easy Academy. In this particular video, we're going to be covering synchronizing our search stores with our database changes using Kafka Connect. So in the first video, we covered the architecture of how the different components interact to make this happen, some of the use cases from the industries where this is really needed, and then we did a setup video as part 2 of 3 of this series. In this particular video, I'm going to be walking you through an interactive demo where changes will be happening at the database in real time. I will do update operations, insert operations, and delete operations, and these changes will be reflected right away in the Elasticsearch index. So that's what we're going to be covering. Now you can follow along with me by going to this repository and taking a look at the code sample. The link to the code sample will be available in the description, and you will be able to check it out and follow along with me. So if you want to follow along, you can just pause the video at this point, and you should be able to do so once you resume. So this is the repo. All you have to do is to go here, copy the URL, and then you can clone the content, and we can proceed. So let's take a look at what we downloaded. So what I want to do now is I want us to head out to the database layer, where we will log into the database and we will interact with the database and perform the insert operations. We will create new rows. We will also perform modifications using update statements, and we will also remove records using the delete statements. So now I have logged in to this database. The other thing I want to do is I want to open the console consumer so that as I'm passing through all these stages, we are watching the changes happen in near real time. So inside the schema registry container, I should be able to get in and we should be able to interact with it. So I'm just going to go ahead and open all of them. All right, so now that we are inside these containers, let's do the following. If you open this Kafka Connect debug, the very first command allows me to watch. So if I copy this one that is eStream65, this is the first topic that contains the raw DB change. So I'm going to head over to this first window over here, and I would watch the changes coming out of that. Okay. Now the second one I'm going to open is going to be eStream75, which is going to allow me to watch the changes coming out of the second Connect instance. So this is 75. All right, and then the last one is going to be 85, which will be the third Connect instance. So let me briefly explain what the differences are. In the first one that says 65, this is the raw DB data. With this data, we have, if we take a look at it closely, you see here that the key of the message is an Azure record, an object that contains the customer ID integer field, and then the value of the record is another Azure record that contains the before and the after. We don't want any of this. We just want the after so that we can push this to our search store. And also we want to use an integer as our key to simplify things, like if we want to do joins with Kafka streams and MySQL DB, that makes things very simple. That's what I want. So that's why in the second one here, I have extracted the key from this customer ID field, and I only have the after portion of the message. But there's a problem, because when we encounter tombstones, there is no value for us to extract the customer ID field, and that causes the system to collapse. We'll take a look at that shortly. But in the third one, I am able to ignore tombstones by using, so if you see here, we're using the value of the customer ID field to insert as the key of the record and do this single message transform. But with the 85 topic, I have a predicate that allows me to skip tombstone records. So that's the key difference between 75 and 85. So in eStreams 75, we are not able to skip tombstone records, and that causes the system to crash. But in 85, we're able to use the predicate record is tombstone and negate that and skip those records that are tombstones, and they just flow through to Elasticsearch and causes the records to be removed from the Elasticsearch index as part of the configuration of the Elasticsearch sync connector. So that's what is the differences here. So I just want to open these three windows so that as I'm performing my operations, we can see those changes happening. So the first thing I'm going to do now is I'm going to go ahead and head back to the DML statement where we're going to insert a new record. So let's do this Easy Bravo record with customer ID 901. Before I do that, let me go into the e-commerce database. Okay, let's take a look at our tables. We have customers. Let's retrieve all of the records and see how many. So we have 20 records. So if I insert this record, we should be able to have 21 records now. So let's see what happened. So if you saw in the eStream 65, we have the customer ID as the Avro record here. We have the body of the value containing the before and after fields. So as you can see here, this is very messy. We don't want to deal with that. But in this one here, it looks like this did not work. But you can see here that we have the customer ID value as the key, and then the after portion is what we have here. And then in eStreams 85, we have the integer, and then we have the value of the after portion, and that is very simplified. So now if we now come and modify this record, so let's go ahead and do that. Let's go back to this section here and let's modify this record. So update customers, set first name equals Israel, I don't want to do this, so I'm gonna cause this to exit. So let's get in again, use e-commerce, select everything from customers. Okay, so update customers, set first name equals to Israel, where customer ID equals 901. So that has modified that record, and let's see what happens. So as you can see here, it has the before and after. The operation is an update. If we take a look at eStreams, you see now that the name has changed from Easy to Israel. Everything else stays the same. So now let's take a look at Elasticsearch and see what's happening if those changes have flowed through. So if we head over to the Elasticsearch, I should be able to search. So let's search. All right, so what is this searching for? This is searching for where first name equals that. So let me change first name equals Israel and let's see what happened. So as you can see here, we have two records that contain Israel as the first name, 607 and 901, which is true because 607 and 901 are now records that contain Israel as the first name. Okay, so we have done an insert, it has showed up. We have done an update, the changes have showed up. Now let's perform a delete and see what happens. So if we now say we're going to delete 601. So I'm going to target to remove where 601 is the customer ID. So let me change this query so that we can actually verify that the first name is James. So right now we're able to see James in 601 and 641 and all these records, but my target is to remove 601. So delete from customers where customer ID equals 601. That affects only one record. If you come over here, you're going to see that a tombstone was sent, and over here the tombstone is reflected. But let's check Elasticsearch and see if those changes. So as you can see, 601 is no longer part of it. So this demonstrates end-to-end how this works. Now, one thing I want to show you is when you actually change the primary ID or the primary key of the record, that causes it to perform a delete on the original row. It also creates a new record. So let's take a look at that for 901. So if I come now and say update customers, set customer ID equals 905, where customer ID equals 901. So set customer ID equals to 905, where customer ID equals 901. Okay, so this is going to be updated. Let's see what happens. But let's watch what happens here. So what happens here is that this performs a delete, and then it performs another insert statement. Let's look at it here simplified. So as you can see here, the 901 was removed and the 905 is created as a brand new record. Now let's take a look at the database and see if we query now by records that have Israel as the first name, we should be able to see 905. So that changes has been reflected. So this concludes our demonstration. We have demonstrated how inserts, modifications, and removals of record from the origin data store can be synced in near real time at the Elasticsearch layer using Kafka Connect. If there's any portion of this, like the schema registry, that you would like to take a closer look, feel free to let me know, and I would walk you through those details. So just let me know in the description what you would like to see as a deep dive, and I will go ahead and do that for you to take a look. So we have schema registry, we have the Elasticsearch. If you want one more on that, let me know. We have Kafka Connect. We also have the REST proxy. So our demonstration has been concluded now. I'm going to go ahead and summarize. If you would like to take a look at the architecture and use cases, that's available in the first video, which you can find in the description. If you want to take a look at how the setup was done, you can take a look in the description for the second video. And in this video today, we covered the demonstration of how inserts to create new records, updates to modify existing records, and delete to remove existing records can be used through Kafka Connect to synchronize your search store in near real time. Now, if you would like to share this content with somebody you think would find it useful, please go ahead and do that, and also subscribe to the channel and like this video so that similar content can be recommended in the future. And if you subscribe, whenever I upload new content, you will be able to find out right away. If you're interested in learning more about Kafka and any other open source data stores or data processing workloads, you can take a look at the course description in the description portion that I set up, and this course allows you to learn this in much more details, giving you an overview of the different categories that are available. And as a data engineer, that's something that you should take a look at. If you are interested in that, look at it and give me your feedback, and I would appreciate that. So that's it for now. I will see you in the next video. If you would like to see anything in more detail, put that as a comment and I will take a look at that and that would influence the content that I do in the future. So thank you for your time, and I will see you soon. Bye bye.